Hello everyone, Ramya, Assistant Professor of CSA Department from Rohini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 3, Topic Syntax Directed Definition. A syntax directed definition specifies the values of attributes by associating semantic rules with the grammar productions. For example, an infix to postfix translator might have a production that rule. This is the given production E tends to E1 plus T. For that semantic rule, you have tried the semantic rule for the given production. This production has two non-terminals E and T. The subscript in E1 distinguishes the occurrence of E in the production body from the occurrence of E as head. Both E and T have a straight valid attribute code. The semantic rule specifies that the string E.code is formed by concatenating E1.code, T.code and the character plus. A syntax directed translation scheme empowers program fragments called semantic actions within production bodies. E tends to E1 plus T of print of plus. The most general approach to syntax directed translation is to construct a parse tree or a syntax tree and then to compute the values of attributes at the nodes of the tree by visiting the nodes of the tree. Syntax directed definition. SDD is a context free grammar together with attributes and rules. Here, the attributes are associated with the grammar symbols and rules are associated with the productions. If X is a symbol and A is one of its attributes, then we have to write X dot A to denote the value of a particular parse tree node labeled X. Synthesized attribute. A synthesized attribute for a non-terminal A at a parse tree node N is defined by a semantic rule associated with the production at N. A synthesized attribute at node N is defined only in terms of attribute values at the children of N and at N itself. Inherited attribute. An inherited attribute for a non-terminal B at a parse tree node N is defined by a semantic rule associated with the production at the parent of N. An inherited attribute at node n is defined only in terms of attribute values at n's parent, n itself, and n's siblings. Example, the syntax directed definition in this diagram, it shows that based on arithmetic expressions with operators plus and asterisk, it evaluates expressions terminated by an end marker n. In the syntax directed definition, each of the non-terminals has a single synthesized attribute called value. We also suppose that the terminal digit has a synthesized attribute lexval, which is an integer value returned by the lexical analyzer. For the given production, each and every production you have to write the semantic rules. The rule for production L tends to En sets L dot val to E dot val, which we shall see in the numerical value of the entire expression. In the production 2, E tends to E1 plus T also has one rule which computes the val attribute for the head E as the sum of the values at E1 and T. At any parse tree node n labeled E, the value of E for E is the sum of the values of val at the children of node n labeled E and T. And a syntax directed definition that involves only synthesized attribute is called S attribute. In an S attribute synthesized directed definition, each rule computes an attribute for the non-terminal at the head of a production from attributes taken from the body of the production. An STD without side effects is sometimes called an attribute grammar. The rules in an attribute grammar define the value of an attribute purely in terms of the values of other attributes and constants. Evaluating a syntax directed definition at the nodes of a parse tree. The rules of a syntax directed definition are applied by first constructing a parse tree and then using the rules to evaluate all of the attributes at each of the nodes of the parse tree. A parse tree showing the values of its attributes is called an annotated parse tree. Before we can evaluate an attribute at a node of a parse tree, we must evaluate all the attributes upon which its value depends. For example, if all attributes are synthesized, then we must evaluate the attributes at all of the children of a node before we can evaluate the attributes at the node itself. A dependency graph or a useful tool for determining an evaluation order for the attribute instances in a given parse tree. While an annotated parse tree shows the value of attributes, a dependency grammar helps us determine how those values can be computed. The two important classes of syntax directed attributes of the S attribute and L attribute. Dependency graph. A dependency graph depicts the flow of information among the attribute instances in a particular parse tree. An edge from one attribute instance to another means that the value of the first is needed to compute the second. Here the edges express constraints implied by the semantic rules. Consider the following production rule. Here in this diagram it shows that every node n labeled E with children corresponding to the body of this production. The synthesized attribute val at n is computed using the values of val at the two children labeled E and T. Ordering the evaluation of attributes, the dependency graph characteristics the possible adders in which we can evaluate the attributes at the various nodes of a parse tree. If the dependency graph has an edge from node M to node N, then the attribute corresponding to M must be evaluated between the attribute N. Here we have the sequences of nodes N1, N2, Nk. Thank you.